Okay, today I'm gonna talk about review for derivatives, application of derivatives, and related the rates problem today. So let me see. Here, the first one, you need to know the table of differentiation formulas. The first one, what is C prime? Could you run your answer on the chatting board? What is C prime? Do you remember C prime? So what is the answer? C prime? The zero? Yes. The constant prime is, yeah, zero. What's X prime? Okay, good. Is one. What's X to the N prime? It's good. N times X to the N minus one. C times F prime is, you can take out C. The C times F prime. F plus minus G prime is F prime plus minus G prime. F times G prime. So we can use product rule. F prime G plus F times G prime. F of G prime is the top one prime times bottom one minus top one times bottom one prime over bottom one squared. What's the sign prime? Do you know what's the sign prime? Could you run your answer on the chatting board, please? The cosine, yep. What is cosine prime? It's good. Yeah, thank you, guys. Next, sine of x. Do you know tangent prime? Is that right? Tangent prime is, yeah, secant square. So what's it like a cotangent prime? Cotangent prime is, do you remember cotangent prime? The answer is, no, yeah, negative cosecant square of x. Cosecant x prime is, what's that? Cosecant x prime? Yeah, negative cosecant times cotangent x. The secant prime is the secant times tangent x. You have to memorize this whole differentiation formulas. Yeah, you're right. So, summary of chain rules. What is it like f of? This is like a typo. So you don't need this x. So you don't need this x. You have to ignore this one. This is typo. We don't have it. F of g of x prime is exactly same to outer function prime of inner function times inner function prime. This is like a chain. So we have it. The next one, what is g of x to the n prime? You can use power rule n times inner function g of x to the power n minus 1 times g prime of x. This is exactly chain rule. So one more, f of g over h of x prime. This is the same to outer function prime of middle one and inner one. So like this, times middle one prime of inner function h times inner function prime. This is exactly the application of a chain. So we have like this. The next, what's the implicit differentiation? Step 1, differentiate the both sides of the equation with respect to x by using the chain rule. Regard y as a function of x. This is a very important thing. Step 2, solve the resulting equation from step 1 for y prime. the example. Calculate y prime. Y prime is dy of dx. First one, y equals 14x cubed negative 3x plus 5 over square root of x. Second one, y equals sine x over 1 plus cosine. The third one, y equals square root of x times tangent square root of x. First one, cosine xy equals x minus y squared. Y equals square root of x minus 1 over x plus 1. The next one, y equals secant square of sine x cubed plus 1. We think about 6 problems together. First one, what's y prime is 14x cubed negative 3x plus 5 prime. How can solve? So do you want to use quotient rule? The quotient rule is possible? Quotient rule, what do you think? How can you find the derivative of this one? The quotient rule is one possibility, it's good, works, but complicated. So let me see. We have only one term in the denominator. What's like the best way? In this case, you have to split. This one minus 3x over square root of x plus 5 over square root of x. You can change it like this. The next, simplify more. The 14x cubed over the square root of x is x to the 1 over 2 minus 3x over x to the 1 over 2 plus 5 over x to the 1 over 2 prime. Can use it. So you can simplify 14 here. X cubed over x 1/2 is x to the 3 minus 1/2 minus keep 3. This power is like 1. The x to the power 1 minus 1 over 2 plus 5 times, you can change it, negative exponent, x to the minus 1/2 prime. So what's that? This is same to 14 x to the 5 over 2 minus 3 times x to the 1 over 2 plus 5 times x to the negative 1 over 2 prime. It's good? Next, take derivative by using power rule. Remember power rule? X to the n prime is the n times x to the n minus 1. So what's that? You can keep coefficient 14 times x to the 5 over 2 prime is 5 over 2, n is like down, x to the 5 over 2 minus 1. Keep negative 3, same. X to the 1 over 2 prime is the power 1 over 2 is down, x to the 1 over 2 minus 1 plus 5 times same. X to the minus 1/2 prime is minus 1/2 is down, x to the minus 1 over 2 minus 1. So simplify. The 2 is crossed out, change 7. 7 times 5 is 35, x to the 3 over 2. 3 over 2. So here, negative 3 over 2, x to the minus 1/2. This is 5 times minus 1/2 is negative 5 over 2. X to the negative 3 over 2. So we have it. The next, change to the positive exponent. This is a positive one, you have to keep. This is 3 over 2 times. X to the minus 1/2 is 1 over x to the 1 over 2 minus 5 over 2 times 1 over x to the 3 over 2. This is not a final. You can change it back to radical form. The 35, was it like a radical form? Do you know this one? So one example, x to the n over 2. How can change? Yes, square root, you're right. This is like a square root of x to the power n. The x to the power n over m. You can change it to the nth root of x to the power n. You can change it like this. So this is the first one. Exactly, you're right. Square root of x cubed minus the 3 times 1 is 3. The 2 times x to the 1/2 is square root of x minus 5 over. The 2 times the x to the 3 over 2 is square root of x cubed. So that's it. This is whole idea for solving this problem. Don't like this. Oh, this is typo. You have to know, doesn't have a C. This is typo. Sorry, this is typo. Ignore C. This is typo. The next is y prime equals sine x over 1 plus cosine x prime. So how can you find this rule? Could you split like this? Is it possible or not? Sine of x over 1 plus sine of x over cosine of x prime. Does it make sense? So what do you think? Does it make sense? Yeah, don't do that. The denominator has like 2 terms, so don't split. The impossible. This is impossible. You cannot do it. No. So how can you find this one? You have to use quotient rule. So first one, top one prime times bottom one. Minus top one times bottom one prime. Over bottom one squared. This is exactly quotient rule. What's the sine prime? The sine prime is, yes, cosine of x. Cosine of x times 1 plus cosine of x minus sine x times what is 1 prime? 1 prime is 0. Cosine x prime is negative sign, you're right. Yes. So like this over 1 plus cosine x squared. Distribute cosine. Cosine x plus cosine squared. The negative sign times negative sign is positive sine square of x over 1 plus cosine x squared. So not yet. You have to simplify more. What is cosine square of x plus sine square? What's that? What is this one? Yes. Cosine square of x plus sine square of x is just 1 over 1 plus cosine x squared. So this is a common factor crossed out. So we have 1 over 1 plus cosine of x. That's it. This is the whole idea for solving this problem. So like this. Third one. So what kind of rule do you want to use for solving root x times 10 root x prime? The which rule is the first? So what kind of rule do you want to use? Yes, exactly. Yeah, product rule. After that, you can just change. So what's the product rule? The first function prime. Here, this is same to the first function square root of x prime times second one tangent of root x plus the first one times second one tangent of root x prime. Was it like a square root of x prime? Here, the square root of x prime is, we can change it to the exponential form. The next, you can use power rule like this. So same to 1 over 2 x to the negative 1/2. You can change it to the positive exponent 1 over x to the 1 over 2. So change it back to square root. So that's it. So what's that? This is 1 over 2 square root of x times 10 square root of x plus square root of x times tangent of square root of x prime. Yes, you can use chain rule in this case. So we use f of g of x prime. This is outer function prime of inner function times inner function prime. This tangent function is like f, square root of x is like g. So what's a tangent prime? What's outer function prime? What's a tangent prime? Yes, we have secant square. Secant square of inner function root x times inner function prime. So this is same to tangent of root x over here 2 times square root of x plus square root of x times secant square of square root of x times the square root of x prime is same. Here we have 1 over 2 root x. So what happens? The square root of x is crossed out. The final answer is the tangent of square root of x over 2 root x plus here the secant square of square root of x over 2. So we have it. This is the answer. So one more. How can you combine? You can multiply the square root of x like this. The same to the tangent of square root of x plus. I want to interchange the square root of x and the secant square. The square root of x times secant, the square of root x over the 2 times square root of x. This is the final answer for solving this problem. The main idea is the product rule and chain rule. So like this. The next one. This is like implicit differentiation problem. You need to find the y prime. How can you solve this one? Here. First one is chain rule. Is right? This first part is exactly chain rule. The chain rule is f of g of x. The prime is f prime of g of x times g prime of x. This is like idea. So what's that? This one is cosine is like log of f, x, y is log of g. What's a cosine prime? Yeah, cosine prime is negative sign. We have negative sine of inner function xy times inner function prime equals here. This is x prime minus y square prime. So you can calculate x, y prime. How can you find x, y prime? You can use product rule. First one prime times second one plus first one times second one prime. What's that? This is x prime is 1. 1 times y plus x times just y prime. So this is same to y plus x times y prime. You can plug into here. We have negative sine xy times whole thing y plus x times y prime equals, what is x prime? What is x prime? Yes, 1. X prime is 1. So we have, this is 1 minus, what is y square prime? What is y square prime? So y square prime is 2y, that's it, 2y. 2y times y prime. So because here, the what is like a y square prime? The 2 is like outer function, y is function, inner function. Outer function prime is 2y, yeah, times inner function prime, y prime. So we have 2y times y prime. The next distribute negative sine of xy to the first and second one. Distribute negative sine of xy times y plus, not negative, this is negative. The negative x times sine of xy times y prime equals 1 minus 2y y prime, the same. I want to move y to the front, so this change like this. Change will be the same to the negative y, like this. The next tip. So you have to isolate the y prime terms. We have 2 y prime terms. This is y prime term. This is y prime term. I want to move this longer one to the right hand side. So you add x times sine xy times y prime. You can add it. Here, you can add it. Times y prime. So cancelled. So one more. You have to move this constant one to the other side. Subtract 1 from both sides. Once you cancel, so what happens? The right hand side has the x sine xy times y prime minus 2y y prime equals. We have this one, the negative y sine xy minus 1. The next, factor out y prime. We have x sine xy minus 2y equals negative y sine xy minus 1. Last step is divide the both sides by coefficient of y prime, x sine xy minus 2y, x sine of xy minus 2y. Crossed out. What happens? This one is exactly y prime. This is the whole idea for solving this problem like this. Do we have it? The next tip. The fifth one. How can you solve the square root of x minus 1 over x plus 1 prime? You can use similar idea. Is that right? For solving this problem by using similar idea. So what's that? You can change this one to the like power rule. X minus 1 over x plus 1 to the power 1/2 prime. Prime. So what's that? This is same to the 1/2 is like down power rule. X minus 1 over x plus 1 to the 1/2 minus 1 times inner function x minus 1 over x plus 1 prime. This is same to 1 over 2, the x minus 1 over x plus 1 to the negative 1/2 times. You can use, how can you solve this one? You can use quotient rule. Top one prime times bottom one minus top one times bottom one prime over bottom one squared. X minus 1 prime is just 1. 1 times x plus 1 is x plus 1 minus same. X plus 1 prime is just 1 negative x minus 1 over x plus 1 square. You have to simplify numerator. X plus 1 negative x positive 1 over x plus 1 squared. X is cancelled. 1 plus 1 is 2 over x plus 1 squared. So we can plug here 2 over x plus 1 squared. So what happens? 2 is crossed out. You can distribute minus 1/2 to the top and the bottom one. So we have x minus 1 to the power minus 1/2. The x plus 1 to the power minus 1/2 times 1 over x plus 1 square. The next, top one is x minus 1 to the power minus 1/2 over bottom one. We have same base. You have to add the exponents. X plus 1 to the minus 1/2 plus 2. The same to x minus 1 to the power minus 1/2 over x plus 1 to the power 3 over 2. This is not a final. You can change negative exponent to the positive exponent. How can change it? The going down. Keep 1, bottom one has x minus 1 to the power 1/2, x plus 1 to power 3 over 2. So change back to radical form. The first one, square root of x minus 1 times the square root of x plus 1 cube. This is answer. One more, combined square root. This is the square root of the x minus 1 times x plus 1 cube. So that's it. This is the whole idea for solving number 5. We have it. The next tip. What's a rule for finding this derivative? So what kind of rule do you want to use? The secant square sine x cubed plus 1 prime. So what's that? So what kind of rule do you want to use? Is it chain rule? Yeah, chain rule. The first one, what is outer function? So which one is the first outer function? The first outer function is, yeah, secant square is right. Yes. I can change a little bit like this. This is exactly same to, was it like a power 2? This is secant of inner function sine of x cubed plus 1 whole thing power 2. This is exact meaning. This is prime. So 2 is outer function down. So 2 times secant of sine x cubed plus 1 to the power 2 minus 1 times the secant of sine of x cubed plus 1 prime. The next one. This is the same to 2 times. The 2 minus 1 is just 1. We have secant sine of x cubed plus 1 times. So here, the secant is outer function. What is secant prime? What is secant prime? What is outer function prime? What is secant prime? Yeah, secant times tangent. So we have secant of inner function sine of x cubed plus 1 times tangent of inner function sine of x cubed plus 1 times inner function. We have sine of x cubed plus 1 prime. You can combine. This is 2 times what happens? The secant sine times secant sine is secant square. Secant square sine of x cubed plus 1 times tangent. Tangent of sine x cubed plus 1 times here. Sine is outer function. Sine prime is cosine of x cubed plus 1 times inner function prime again, is right? Prime again. So what's that? You can only calculate only this one. X cubed plus 1 prime. What's x cubed plus 1 prime? What's x cubed plus 1 prime? Yes, 3x squared, 1 prime is 0, exactly 3x squared. So this is 3x squared. We can combine 3x squared times 2, exactly the 6x squared secant the square of sine x cubed plus 1 times 10 sine x cubed plus 1 times last one cosine of x cubed plus 1. So that's it. This is the idea for solving number 6. That's right. This is the whole idea. The next tip. Do you know like normal line? The normal line to a curve C at a point P is the line through P that is perpendicular to the tangent line. So what does it mean? So we have curve is given. This is curve. I can draw tangent line. choose point P here. This is tangent. What's the normal line? The passing through P, this is perpendicular to the tangent line. So we call this is a normal line. So this is like a normal line. Is right? This is the definition. So like this. What's the equation of a tangent line? To memorize. Y minus f of a equals f prime of a x minus a. What's like an equation of the normal line? The y minus f of a equals minus 1 over f prime of a times x minus a. This is like equation of the normal line. So we have this one. We can try to solve this problem. Find equations of the tangent line and the normal line to the curve at the given point y equals the square root of 5x plus 4 and 1, 3. So what's that? What's the first one? So f of x equals the square root of 5x plus 4. Is right? You can take a derivative. So let me see. I can write the first one, the equation of a tangent line. What's it like equation of a tangent line? The equation of a tangent line is y minus f of a equals f prime of a times x minus a. What's it like equation of a normal line? The normal line is y minus f of a equals negative 1 over f prime of a times x minus a. This is like whole idea, is right? The first problem, what is a? What is a? Is the first problem. What is a? Yes, x component to 1, you're right. This is 1. What is f of a? What's f of a? Yes, y component to 3. So from here, we can plug y minus the f of a is 3 equals f prime of a is 3 times x minus 1. Oh, this is 1. F prime of 1. Sorry, f prime of 1. What's it like equation of normal line? Similar. Y minus 3 equals minus 1 over f prime of 1 times x minus 1. So like this. What's it like main things? You need to find f prime of 1. First, you can find f prime of x. F prime of x is the square root of 5x plus 4 prime. You can change the square root of 5x plus 4 to the this is exponential form, 4 to the power 1/2 prime. So you can use power rule and chain rule. 1 over 2 is down, 5x plus 4. 1 over 2 minus 1 times inner function 5x plus 4 prime. You have to keep 1 over 2, the 5x plus 4 to the minus 1/2 times the 5x plus 4 prime is just 5 and combine. This is 1 over 2, 1 over. Change it. 5x plus 4 to the 1/2 times 5. The exact same to 5 over 2 times square root of 5x plus 4. The next, you need to calculate f prime of 1. F prime of 1 is plug 1 into this x, 5 over 2 times square root of 5 times 1 plus 4. 5 over 2 times square root of 9. What is square root of 9? The square root of 9 is, what's that? Yes, positive 3. 5 over the 2 times 3 is 6. We have it. So what's like equation of a tangent line? So from here, equation of tangent line is y minus 3 equals 5 over 6 times x minus 1. That's it. This is the equation of a circle. What's like normal line? Y minus 3 equals, you plug 5 or 6 into denominator, minus 1 over f prime 1. What's that? Reciprocal, take negative sign. Yes, negative 6 over 5. Negative 6 over 5 x minus 1. So that's it. This is the whole idea for finding the equation of tangent line and the normal line. This is like idea. So it's good. It's good. The next one. How can you find the equation of tangent line to the second one? You can use same idea. So here, you can use same idea. Here, erase everything. Yep, here, everything. So we can use same things. Only difference is here. So what is A? A is 2. F of A is 1. You can replace the next one. A is 2, F of is 1. You can erase 3. This one. So what's that? Here, you can plug A into here. A is 2. A is 2. F of A is 1. A is 2. Is 1. This is 2. This is 2. So like this. So how can you find F prime of 2? You can use implicit differentiation. So we have x squared minus 5xy plus 4y cubed prime equals negative 2 prime. So what's that? X squared prime is 2x minus 5 exactly xy prime. What's it like xy prime? You can write x times y prime is x prime times y plus x times y prime. X prime is just 1. Y plus x times y prime. So we have plug parentheses y plus x y prime plus. You can keep for find y cube prime. What is y cube prime? Could you run your answer? What is y cube prime? Y cube prime is the 3y squared times y prime, right? The outer function prime is 3y squared times y prime equals negative 2 prime is 0. So we have 2x minus 5y plus, minus the minus 5xy prime plus 4 times 3 is 12. Y square, Y prime equal to 0. So next, what is like X value? X value is 2. Y value is 1. You plug into equation, so what happens? You can plug 2 into X. We have the 2 times 2 minus 5 times Y is 1 minus 5 times 2 times Y prime plus 12 times the Y is 1, 1 square. 1 square times Y prime equal to 0. So what's that? 2 minus 5, the 4 minus 5 is negative 1. This is negative 1. This is negative 10 y prime, 12 y prime. Negative 10 plus 12 is plus 2y prime. So equal to 0. You just only add 1 to the both sides. 2y prime equals 1 divided by 2. Y prime equals 1 over 2. So this is slope. You can plug into equation of tangent. Y minus 1 equals 1 over 2 x minus 2. This is equation of tangent line. What is the equation of normal line? Similar. Y minus 1 equals plug 1 over 2 into bottom one. The reciprocal is 2. Take negative sign, minus 2, x minus 2. So that's it. This is the whole idea for solving this problem. So we have it like this. That's good. The next one, the limit problem, I want to skip because this limit problem is deal with some of the kasha yesterday lecture. You can check yesterday lecture. So you can find the answer of this question. So I want to skip this one. So like this, just skip. One more question. Did you learn this one yesterday? So what do you think? Did you learn this stuff or not? So if you don't learn this kind of problem, I explain to you. If you learn this stuff in the yesterday, I don't explain the more. So could you learn how can you find this kind of limit problem? Do you know or not? So if you don't know, I'll explain right now. It's good, depending on your choice. So what do you think? So did you learn this limit problem? So did you learn or not? Oh, okay. Okay, I see. You didn't learn. Okay. Okay. So what's like an idea for solving this problem? So you can use, this case is, it's not is to factors, right? It's not is to factor. So this one, not is to expand. 1 plus h is 21. Same. Cube root of x, don't multiply conjugate. The cube root of x plus 4, cube root of x, you cannot multiply the cube root x plus 4. You cannot cancel cube root, impossible. So how can you solve this complicated problem? You can use definition. The limit, you can change it to the f prime of a. This is like a whole idea for solving this problem. I can show some problems here. You can compare with limit f of x minus f of a over x minus a equals f prime of a. So like this. You can find step 1. Find a first. What is a? What is a? You can compare this one with this limit. What is a? Yes, a is 1. A is 1. It's good. What's f of x? Yes, exactly this side. X to 21. So step 2, take a derivative. X to 21 prime is 21 times x20. The next, was it like a final answer? You can plug 1 into here, 1, 1. Final answer is f prime of 1. Step 3 is find f prime of 1. Plug 1 into here. The 21 times 120 is 1, exactly 21. That's it. This is answer. This answer is 21. So similar. In this case, compare with f of a plus h minus f of a over h. Can compare. So same. You can decide a. What is a? What is a? The 1. You can compare with inside 1. This is 1. Yes. What's f of x? F of x is, you can compare. This is what? So far, age 1, age 1, age 1. You can compare. F of 1 plus h is 1 plus h to the 21. F of 1 plus h is exactly same to 1 plus h to the 21. You can replace 1 plus h by x. What does it mean? Replaced by x. Replaced by x. We have x21. This is the idea. F of x is x21. Only compare this one. Only replace a plus h by x. X to the 21. Step 2, same. Take derivative. X to 21 prime is 21 x20. So what's that? A is 1. The final is calculate f prime of 1. So plug 1 into x, the 21. That's it. This is the whole idea for solving this problem. Here, same things. Compare. What is a? The a is not 4. The 4 is f of a is 4. What is a? Yes, 64. What's f of x? F of x is, yes, cube root of x. Exactly, top on the left. Same. Find derivative. Cube root of x prime is changed to the exponential form. X to the 1/3 prime, use power rule. The 1/3 times x to the negative 2/3, change to the positive exponent, 1/3 times x to the 2/3. So next, was it like a 64? So you can plug 64 into here. So exactly like this. You calculate 1/3 times. Was it like a 64? I'm going to change it like this one. 4 cube. The 4 cube is 64 to the power 2/3. 3 is cancelled. 1/3 times 4 square. This is 1/3 times 16. Final answer is 1/48. This is the answer. It's good? So like this. Second one, you can compare with limit f of a plus h minus f of a over h. The similar. What is a? The a is, what is a? No, inside one. 64 inside one. What's it like a 4? 4 is the same to cube root of 64. This 64 is exactly a. This is a 64. What's f of x? Yes, cube root of x, same thing. A is 64. We can compare this one with this one. So f of the 64 plus h is the cube root of 64 plus h. You can replace 64 plus h by x. F of x equals cube root of x. So same. Second step, exactly same to top one. Take a derivative. The last step is exactly same to top one. This is answer. This is the whole idea for solving complicated problem by using definition of the limit. The definition of the derivative. It's good. It's good. Okay, this is I think very sufficient for this kind of problem. The next one. S equals f of t is the position function of a particle that is moving in a straight line. F prime of t equals v of t, like velocity, is right? The second derivative is v prime of t is you write a of t, we call acceleration. The absolute value of v of t is speed. This is like a definition. The one note. The velocity is positive. What does it mean? Particle moves forward in the positive direction. The velocity is negative. So what does it mean? Particle moves backward in the negative direction. The v of t, this is like a typo. If the velocity equal to 0, then the particle is at rest, doesn't move. The one more, absolute value of v of t is increasing. What does it mean? Speed is increasing. So we have speeding up, particle speeds up. The v of t and the AAT have the same sign. Then particle speeds up. This is like the same things. The v of t decreasing, the speed is decreasing. So what does it mean? Particle slows down. So when this slows down, the velocity, acceleration have opposite sign, positive, negative, or negative, positive. Then the particle, this is all the typo, the particle slows down. Example, the position of a particle is given by the equation S equals f of t equals t cubed negative 9t squared plus 24t plus 1, where t is measured in seconds and s in meters. First problem, find the velocity at time t. When is the particle at rest? When is the particle moving forward? When is the particle moving backward? Find the total distance traveled by the particle during the first 5 seconds. Find the acceleration at time t. The last one, when is the particle speeding up? When is the particle slowing down? This is like all questions. So here, how can you find the v of t? How can you find the velocity? Do you know? How can you find the velocity? Yes, the derivative of position function. F prime of t is t cubed negative 9t squared plus 24t plus 1 prime. Exactly. First one, 3t squared negative 9 times 2t plus 24t is 24, 1 prime 0. So we have it. So like this. Second one, particle and rest. So what does it mean? Velocity is, what does it mean, the and rest? Yes, velocity equal to 0. We can factor out 3 from the here. Next, factor out 3 times t minus 2, t minus 4 equal to 0. The velocity equal to 0, you solve. T is 2 and 4. So that's it. This is answer of B. Third one, particle moving forward, moving backward. How can you check? Moving forward and backward. You can use this result. So what does it mean? Here, this is time interval from 0 to infinity. You plot, so this is like 0, starting point 0 to positive infinity. You plot 2 and 4. You can check velocity is positive or negative. I'm going to choose test number here. Test number 1. You plug 1 into velocity. 1 into here. 1 minus 2 is negative. 1 minus 4 is negative. Negative times negative is positive. So like this, I can choose 3. Test number. You plug into t. Again, 3 minus 2 is positive. 3 minus 4 is negative. Positive times negative is negative. So one more here. Choose 5. You plug into t again. So 5 minus 2 is positive. 5 minus 4 is also positive. Positive times positive is positive. So what's that? Velocity is positive, moving forward. Negative, moving backward. Answer is next one. So the moving forward. Answer is moving forward. The when. Positive one. T is between 0 and 2. The T is between 0 and 2 and greater than 4. Moving forward, moving backward. The when, exactly 2 to 4. Time interval is between 2 to 4. So this is the idea. Moving forward, moving backward. So like this. The D. What's the D? Find total distance traveled by the particle during the first 5 seconds. First 5 seconds. So how can you find this kind of things? So this is like idea. Here, from 0 to 2, moving forward, 2 to 4, moving backward, T to 4, moving forward again. Is right? So you can draw the diagram. So we think about like this. You calculate this one here. You can draw a diagram. What happens? This is like time, I don't know, this is some position of a particle here. Time t equal to 0 here, moving forward at time t. Time, the t equals 2. And moving backward at time t equals 4. Moving forward again. So you can define exact position at time t equals to 0, time t equals to 2, time t equals to 4. The last one is, this is time t equals to 5, first 5 seconds. So you calculate f of 0, f of 2, f of 4, f of 5. What's f of 0? You plug 0 into position function. Do you remember position function? Position function is here. Plug 0 into this t. So we have like this. Just 1. You plug 2. 2 cube, negative 9 times 2 square, plus 24 times 2 plus 1. The calculation is up to you. Answer is 8 minus 36 plus 41 plus 1. The 21 is right. This is 21. Can f of 4. 4 cube, negative 9 4 square, plus 24 times 2. The 64 minus 144 plus 96 plus 1 is 17. So we have 17. f of 5 is like this. 5 cube, negative 9, 5 square plus 24 times 5 plus 1 equals, like this, calculate 21. It's good. So what's it like a diagram? Diagram is not difficult. So we have like this. This is 1. This is starting point. Time t equaled 0. Moving forward. Moving forward, this is time t equals 2. This one is 21. Moving backward, so here, this is time t equals 4. So we have 17. Moving forward again, this one is time t equals 5, same position, 21. So first, what's like a total distance? The total distance is the first one, this length, exactly 1 through 21. Exactly first one, 21 minus 1, plus second one, the 17 through 21, plus 17 minus 21 minus 17, 21 here, the 21 minus 17 plus. The next piece is here. This length, the same thing, 17 through 21. So we have 21 minus 17. So here, 21 minus 1 is 20, plus 21 minus 17 is 4. So again, 4. Answer is 28 meters. This is total distance. This is the idea. It's good. If you have any trouble, any question, lecture is very fast, please let me know. I can just slowing down or explain the more or something like that. Always ask on the chatting board. So like this, 28. The next one, was it like a of t? The second derivative. The second derivative is like a velocity prime. The velocity is from the problem A, 3t squared minus 18t plus 24 prime. You can calculate 6t minus 18. We have it. A of 4 is 6 times 4 minus 18 is 60 meters per square seconds. It's like acceleration at time t equals 4. So let me see. We can just sketch the graph, the velocity and the acceleration. So why do you need this graph? So let me see. We are going back to our problem. The last problem is here. When is the particle speeding up? When is it slowing down? So if you don't find this kind of answers, so what's the best way? We have 2 methods. The absolute value of v of t is increasing, particle speeds up. Another one, the v of t, a of t, the same sign, particle speeds up. The absolute value of v of t is decreasing, particle slowing down. So another way is the velocity and the acceleration have opposite sign, the particle slows down. So this is the reason. You can draw velocity graph and the acceleration graph. Here, going back. This one, the graph is like this. The velocity is 3 times t minus 2, t minus 4, exactly red one. This is velocity. The a of t is like a blue one, the blue one. So you can check what happens 0 to 2, the time interval 0 to 2, the velocity is negative, acceleration is also negative. Is right? Velocity is positive, like above x-axis. Acceleration is below the x-axis, negative. The blue one is negative. The red one is positive. So what does it mean? Slows down. We have a different sign. T is between 2 and 3. What's that? The 2 and 3. The red one is negative. Blue one is like negative. We have the same sign, speeds up. The time t is between 3 and 4. 3 and 4, what happens? Here, blue one is positive. Acceleration is positive. Red one is like, velocity is like negative. We have different sign, slows down. Last one, t is greater than 4. Here, this one. The red one is positive. Blue one is going up, also positive. We have same sign, speeds up. This is the whole idea for solving this kind of problems. That's good. So this is the whole idea. The another method is use the graph of speed v of t. What's the v of t? This one. You can just sketch the graph. What happens? Like this. The v of t is exactly inside 1. The graph is 2 and 4. Graph is like this, 2 and 4. What is absolute value of v of t? The absolute value of v of t is, so this is same, 2 and 4. Positive one is also positive. What's like a negative one? You have to reflect about x-axis. Graph is like this. So we have it. This is absolute value of v of t. So how can check speeding up, slowing down? So we can use this idea. The absolute value of v of t is decreasing from 0 to 2, slowing down. The 2 to 3 graph is increasing, speeding up. The 3 to 4 graph is decreasing again, slowing down. The 4 to infinity graph is increasing, speeding up. This is another method for checking speeding up and slowing down. This is the whole idea. So far, do you have any question? So if you have any question, write your the question on the chatting board. If you don't have any question, please write no on the chatting board, please. Okay, good. So this is like the last one. The last one is we try to solve 2 related rate problem together. So how can you solve related rate problem? Step 1, draw a diagram if possible and introduce notation. Step 2, express the given rate, the unknown rate in terms of derivatives. Step 3, write an equation that relates the various quantities of the problem. Step 4, use the chain rule to differentiate both sides of the equation with respect to time t. Step 5, substitute the given information into the resulting equation and solve for the unknown rate. Okay, this is the whole idea for solving related rate problem. We always follow 5 steps. This is first problem. The ladder 20 feet long rests against the vertical wall. If the bottom of the ladder slides away from the wall at a rate of 2 feet per second, how fast is the top of the ladder sliding down the wall when the bottom of the ladder is 15 feet from the wall? So let me see. Step 1, diagram and notation. What's like diagram? Here. So we need vertical wall. We have ground. So what's that? 25 letter rests against the wall. This is the letter against the letter of the wall, like this. This is 25. So what happens? Letter slides away from the wall. This bottom one is going forward. Was like top of the letter sliding down. Top of the letter sliding down. This is exactly, yeah, dx of dt equals to, you're right, thanks. This is diagram, like this. The distance from the bottom of the letter to the wall, we can write x. The distance from the top of the letter to the ground is y. The t is like time. Step 2. You can find the given rate, the unknown rate. What's given rate? Given rate is dx of dt is given here. Exactly. Bottom of the letter slides away. What does it mean? The increase, the rate of increase of x with respect to time t. So we can write dx of dt equals 2 feet per second. Was it like unknown rate? Was unknown rate? Yes, here. How fast is the top of the letter sliding down the wall when the bottom of the letter is 15? The bottom of the letter is 15 feet from the wall. Exactly, x is 15. So we have this one. The rate of decrease of y with respect to t when x equals 15 feet. We use dy of dt at x equals 15. This is like a whole idea. So, step 3, you need to find equation that relates x and y. How can you find the equation relates x and y here? Yes, Pythagorean theorem. This is exactly right triangle. X squared plus y squared equals 25 squares. You can use it. So like this. Step 4, differentiate. You can take a derivative of both sides. What is dx squared of dt? What is dx squared of dt? 2x, that's it, only 2x. The 2x times dx of dt, because what's the variable? Variable is t, this is key. Variable t, we have 2x dx of dt, y squared prime is 2y dy of dt, the 625 prime is like 0. The next, the divided by 2, the both sides, 2 is gone. Exactly, x dx over dt plus y dy over dt equal to 0. Step 5, substitute and solve in the equation for dy over dt. So let me see. Was it like a given rate? Here, given information. So here, given information is dx over dt equals to 2, so x equals to 15. This is like all given information. dx over dt equals 2. dy over dt is unknown, so x equals 15. So you plug x equals 15 into here, the dx over dt into here. How can you find y? How can you find y? Yes, we can going back to diagram again here. Was it like a diagram? This is diagram. So letter is 25. This is x. This is y. X is given 15. You need to find y. What's y? You can just sine function or something. It's good. The Pythagorean theorem is one idea. You can use x squared plus y squared equals 25 squared. Find y. The another method is you can use spatial ratio. Do you know spatial ratio like this? Yeah, 3, 4, 5. This 25 is exactly 5 times 5. The second one is 3 times 5 is 15. This side is 4 times 5, exactly 20. So y is what? 20. You can plug 20. So you can plug. X is 15 times dx of dt is 2 plus y is 20 times dy of dt equal to 0. The 15 times 2 is 30. You subtract 30 from both sides. So 20 dy over dt equals negative 30. Divided by 20 is gone. Exactly. dy over dt is negative 3 over 2. This is the whole idea. So we have like this. And so it is negative 3 over 2 feet per second. The last problem. A water tank has the shape of an inverted circular cone with a base radius 2 meters, height 4 meters. If water is being pumped into the tank at a rate of 2 cubic meters per minute, find the rate at which the water level is rising when the water is 3 meters deep. It's like a question. Step 1, diagram and notation. So what's it like inverted circular cone? You can draw inverted circular cone. So like this. Radius is 2, height is 4. So what happens? Water is being pumped into a tank. The water level is increasing. This is like water. This is here. So we need radius. We need height. Water level is h. The volume is v. So we need these kind of things. Is right? So like this. V is volume of the water. H is the height of the water. R is radius of the surface. T is time. Step 2. The given rate, the unknown rate. What's the given rate? What's the given rate? No. The given rate is here. 2 cubic meters per minute is given rate, exactly the rate of change of volume with respect to time t. So we have the next one. The dV of dt is 2 cubic meters per minute. This is given rate. What's the unknown rate? Yes, unknown rate is, you need to write the dH of dt here. The rate at which the water level rising, the water level changes. So we have the rate of increase of h with respect to t when h equals 3 meters. dH of dt at h equals 3. So we have this one. It's good? The next equation that relates volume and h. So do you know what's the volume? What's the volume of this one? What's the volume? Yeah, 1/3 pi r square h. You're right. The volume is 1/3 pi r square h. Is right? So let me see. Was it like some the unknown thing is we have the v and h. So from step 2, we don't have r. Is right? We don't have dr over dt. So we don't have it. So what does it mean? You have to eliminate r. How can you eliminate r? So this one is express v as only a function of h alone. Eliminate r. How can you eliminate? You can use similar triangles. Going back to diagram again. So what's that? This is right triangle, bigger one. This is another right triangle. This is a common angle. This is same angle. We have two similar triangles. You can draw bigger one. The bigger one is here. So like this. This is 2. This is 4. You can draw a small one. This small one. Small one is here. Here. This is R and H like this. So we can use proportion. 2 over R equals 4 over H. You can use cross multiplication. So 4 times R equals 2 times H divided by 4. R equals 1 over 2H. You plug this value into here. What's it like a volume? Volume is 1/3 pi times 1 over 2H squared times H. 1/3 pi times 1 over 4 H squared times H. Change it to the 1 over 12 pi H cubed. So this is exact volume, right? We have it like this. We have it. Step 4, differentiate. Take derivative. The first one, dv of dt. Here, take out pi over 12. Pi over 12 d over dt, d of h cubed. What's that? What's it dh cubed over dt? Do you know answer? dh cubed over dt is 3h squared times dh over dt. You can use like power rule. Pi over 12 times power rule 3h squared times inner function prime. dh over dt. 3 is crossed out, 4. Answer is pi over 4 h squared times dh over dt. Is right? This is exactly dv over dt. So we have it. So like this. Last step, substitute and solve the equation for dh over dt. So how can solve? Here, the given information is from step 2. Here, dv over dt is 2 cubic meters, h equals 3. Is right? So here, so we have given information dv over dt equals 2, the h equals 3. You plug into here, we have 2 equals pi times 3 squared over 4 dh over dt. So what's that? This is same to 2 equals 9 pi over 4 dh over dt. The last one, you have to solve this equation for the unknown rate, dh over dt. So you can multiply the both sides by reciprocal of coefficient of dh over dt, 4 over 9 pi. The 4 over 9 pi. What's that? 4 is crossed out, 9 pi crossed out, dh over dt equals 8 over 9 pi. So that's it. This is the whole idea for solving this problem. Okay, so this is all for today's lecture. So if you have any question, could you write your question on the chatting board? If you don't have it, you can leave this live session. I will upload some so yeah, you're welcome. You're welcome. Yeah. So thank you for attending my class. I appreciate. So see you later. The same. If you have any question, write your question on the chatting board. If you don't have it, just leave a live session. Yeah.